let us know the arrangement of resistors in the circuits. Let's see. So this is a simple diagram of resistors in series, where you can able to see the resistors are being connected in a N to N, or you can say they both are connected in a linear way. Clear? Where the batteries are there, the resistor are there. Clear? Here I have just shown you only two resistor. Clear? The more details you will learn in our next slide. Clear? Here, the property of resistor in series. Number 1, you see the equivalent resistance is equal to the sum of the individual resistance. Means what? If you want to find out the equivalent resistance, you just go on adding the value of the resistance in the given circuit. Clear? So to find out the equivalent resistance in a series arrangement, you just go on adding. Clear? The values. Okay, now the point number 2, the current through each resistor is same. Means the current will be same in the resistor. Clear? Third point, the potential difference across each resistor is different. Means the potential difference across each of the resistor is different. Clear? So this all we will learn in the next class. Here you see the resistors in series. So how to calculate the equivalent resistance or the total resistance in a series? So according to the first property which I have shown you, that the equivalent resistance is equal to the sum of the individual resistance in the circuit, isn't it? So here you can see, so this particular is called what? The equivalent resistance or the total resistance. So here you can add it as much as the resistance will be there in the circuit in a linear way. If you will add it, so you will get the total resistance, or you can say the equivalent resistance. Clear? So this is a type, or you can say it is a process to find out the equivalent resistance. Clear? In a series arrangement. So the first point, you see, in the disadvantages of series combination, it is given that in this combination, if any component fails to work, okay, here component means what? The resistor is telling about the resistor. So if any resistor fails to work, then the current will break and none of the component will work. Okay, you know how the resistor are being connected in a series. Means what? They are connected in a linear way. Okay, means one in this way, means one another. Okay, this means the one end to the other end, isn't it? So if one of the resistor is been burned or got damaged, then the other resistor which is been connected with that particular resistor which is burned, okay, then the good one, means which is operable one, will also not operate, isn't it? Then the circuit which is been connected, then it will become a open circuit, then the current will not flow. Clear? So it is telling that the series arrangement is a kind of disadvantage. Second point, it is not possible to connect a bulb and a heater in series because they need different values of current to operate properly. Clear? This thing, so in this diagram you can see, and you can able to understand more clearly the disadvantages of series connection. This is a diagram. So this is positive, this is negative. The current will flow from this end to this end, isn't it? Now from these two resistor, okay, these two resistor, if any one of them is burned or got damaged, then suppose this particular is damaged, then what will happen? The current will not able to flow from positive to negative. Now when the current will not able to move from positive to negative, then what will happen? The circuit is not complete. Now when there is no completion of circuit, then there is no any potential difference. So no potential difference means no current will flow, and this will not operate nicely, being it is a good one. So this, suppose this is a good one, this is bad one. So if this got damaged in a series, it will not operate, since the circuit is not able to fulfill the full circuit. Okay, means it is unable to complete the circuit. Clear? So resistor in series, okay, this has some disadvantages. Clear? This is a simple diagram of resistors in parallel. Clear? So here you can see that the battery is being connected with the resistor, and you can easily see the difference between the series arrangement and the parallel arrangement. In series, what happened? You have observed that the resistors are being connected end to end in a linear way. Clear? But now in the parallel arrangement, the resistors are being connected in one above the other. Clear? One above the other. Clear? So we will learn it in a more detailed way. Clear? Properties of resistors in parallel. So it will be the just opposite of the properties of resistor in series. So in the first point, you can see the reciprocal of equivalent resistance is equal to the sum of the reciprocal of individual resistance. Okay, in earlier, the property of resistor in series, to find out the equivalent resistance, we just add all the resistance, clear, the value of the resistance in a linear way, isn't it? R1 plus R2 plus R3 in this way. But now here we will do it in a reciprocal way. Clear? Okay. The next point, you see, the current from the source is greater than the current through each resistor. Clear? Means what happened? The second point, it's saying that the current in the parallel arrangement, it means the current will be not constant. Clear? It means it will be different for the different resistor. Clear? It may be same also. Okay, we will learn it more clearly in our next slide. Clear? But just you think that in the parallel arrangement, the current, it is not constant. Clear? Just the opposite of the series arrangement. The next, the potential difference across each resistor is same. Earlier what happened? The potential difference across each resistor was different, but in the parallel it is same. Clear? Okay, let's see in the next slide. We will able to know more details about the property. Clear? To find out the equivalent resistance in the parallel arrangement, so we can do it by reciprocal. Clear? The first property is what? 1 by R total. R total means the equivalent resistance. Clear? Equal to 1 by R1 plus 1 by R2 plus 1 by 3. Okay, 1 by R3 in this way. Means the number of resistance, means how many the number will be there, you just go on adding in a reciprocal way. Clear? In the parallel arrangement, in this particular point, you see, in this particular point, the current which will come from this positive point to negative point. Clear? At this particular point, the current will split up and the current will move to R1 and the current will move to R2. Clear? Now when the current will split up at this particular point, then the current will be different for R1 and the current will be different for R2. Clear? Then again the split up current will join here. Clear? That means the I means the current will be equal to this particular I and this particular I. Let us imagine that in R1 the I1 current is coming and the I2 current is flowing through R2. Then I will be equal to I1 plus I. Let us see the conclusion. Here we can see in the first diagram it is a parallel arrangement where we learned that to find out the equivalent resistance we will add the resistors. Okay, we will add the resistor in a reciprocal way. Clear? Also the current, you can see the R1 the current is I1 and in R2 the current is I2. Clear? Means current is different for the different resistor in the parallel arrangement. In the second figure you can see the series arrangement of the resistor. Clear? Where current is flowing in a linear way and the potential difference is different for the different resistor. Similarly, to find out the equivalent resistance we will add the resistor. Clear? The value of the resistance means the resistor which have a property of resistance. Clear? We will add all the resistor in a linear way. Clear? So this is all about the introduction of series and parallel arrangement of the resistor. We will learn more in a detailed way about the series arrangement and parallel arrangement in our next class.